All right, give it a try, give it a try, try. Okay, first thing to do is to convert to parametric form. So you should end up with a system, something like 1 minus 3s equals -1 plus t. 2 plus 5s is 3 minus 4t. 1 plus s equals 1 minus t. So 3 equations, 2 variables. Solve for s and t, and then take your whatever s you find and plug it back in here. And then this should pop out as your answer. Okay, let me know how that goes. Okay, where are we now? Where are we now? Oh, here we are. Okay. A big example here. Trying to go through carefully. Pause, copy, pause, copy. Now, first things first, find the equation of the line. So here's my line L. And we'll say A is here. We'll say B is here. I want to find the equation of the line. The first thing I notice is that the direction vector is right in front of me. So let's just imagine the origin is here. Doesn't really matter. If I look at the vector AB, this vector that goes like so, okay, that can serve as a direction vector. Okay, that is a vector that is certainly parallel to the line. So when I find my line, so P is equal to P0 plus TD, my first step is to just put in AB for the direction vector. P0, I just need one vector on the line. Could be any vector you want. I could use this one, or I could use this one. Those are the two obvious answers. I'll just use whatever. I'll just use this one. We'll call it lowercase b. And there we have it. We have our line pretty much sorted out. I just need to find b. Well, b is this vector formed from this point here. And then AB is a subtraction. I'm going to take, it's kind of like you take the point A and you subtract the point A. Oh, sorry, you take the point B and subtract the point A. So, sorry, write these as vectors. The vector B minus the vector A, rather. It's probably more straightforward. So I get 4, 4, 4 minus 0, 8, 2, giving me 4 minus 4, 2. Okay, so my line equation is complete. 4, 4, 4 plus t times 4, negative 4, 2. So part A, there's my answer. Now part B is trickier. We have the same line. Let's draw it again. We got A, we got B. And I'm trying to find this point C here. Let's call it point C. And we want the point C to be 3 units from A. And we want it to be between A and B. Okay, so it's not this one over here. It's this guy here. Okay, what to do? Well, first thing I'm going to notice is that I got my direction vector. Let's say the origin is here. I got my direction vector for the line. The first thing I notice is that, let's make it a bit longer just to let's say the direction vector is super long, whatever, or longer. First thing to notice is that this direction vector and the vector AC here are parallel. So AC is some multiple, we'll say t, times my direction vector d. Okay, hopefully that's clear from the picture. This vector and this vector are parallel, so one of them is a multiple of the other. That's what I've written down here. So AC is going to be something times my direction vector, which I've written up here, 4, negative 4, 2. Now I'm trying to find the point C. I can solve for it in this equation here. Kind of. Oh, I got two variables. I got C, I need to find C, and I also have a variable T. So I have two variables. So I have to use my other piece of information, which is that the distance between A and C is going to be 3. That's given in the question. So what does that mean? That means that I take this guy, stick it in here, and hope for the best. So I got AC is 4t minus 4t, 2t, which is 3. As a good math student, I factor out my common factor, which is 2t, being careful to put an absolute value on it when it comes out. 2 minus 2, 1, 3. So this is 2t times the length of this guy, which is going to be 4 plus 1 is 3. And what do you know? This is 3. This is also 3. So they cancel when I divide. So absolute value of 2t is equal to 1. What does that tell me? What does that tell me? It tells me the absolute value of t is a half. So t is equal to plus or minus a half. Now, but if I remember my diagram right here. Right here, you know, I want AC and the direction vector D to be pointing in the same direction. Okay, you'll remember that the direction vector D was AB. Okay, so I certainly want AC and T times D to be going in the same direction. So that for that reason, I will choose T is equal to plus a half. Okay, now I can find my point C. I'll go back to this equation here, bring it down here, so I get AC is 1/2 4, negative 4, 2. So that is the vector C minus the vector A is equal to 2 minus 2, 1. And the vector A is given, if I'm not mistaken, yeah, the vector A is given to be 4, 4, 4, 4, 4, 4, 2 minus 2, 1. So finally, my vector C is 6, 2, 5, which tells me the corresponding point is 6, 2, 5. Et voilà.